Hello everyone. I'm audible. I'm audible, guys. Hello. Hello everyone. Hello. Is my voice clear? Reply in the chat, guys. Is my voice clear? Good evening, everyone. Good evening. Hello, Diksha. Hello, YT Thakur. Good evening, everyone. Good evening. So we'll begin the session. Just 5 minutes. Let everyone join. Good evening. Let's just wait for 5 minutes, and then we'll start the session. Hello, Shibam. Sorry. So is my voice audible, right? Is this clear? Is my voice clear? Yes, sure, Jason is the best mentor. Yes, I also agree that. Great. My voice is clear, right? So we'll start the session in 2 minutes. Hello, Gaurav. Hello. Hello. So this is the day 4 of the bootcamp, right? Till now, we have covered the what is data science, first of all, the basics, like what is data science, what is machine learning, and some Python basic concepts in day 1, right? In day 2, we have covered the important libraries like NumPy, Pandas, Matplotlib, and everything. Hello, Rebel Emojit. Hello, Kushi. Hello, Gaurav. So, day 2, we have covered the important libraries like NumPy, Pandas, Matplotlib, and Seaborn. Not Seaborn, NumPy, Pandas, and Matplotlib only. And we have gone through the dataset as well in day 2. Hello, Vidhamya. Hello. And in day 3, we have covered the mathematical intuition behind XGBoost specifically. Why only XGBoost? Because we are going to use XGBoost in the our model only. So today's session is totally practical session. First, take attendance नहीं fill करता था network issue. No worry, Gaurav. Just fill the attendance of all the other 4 days, and you will get the certificate. Don't worry. So today's session is purely based on practical part. We will just firstly pre-process the dataset that have given to us, and then we will apply the model. We will check the accuracy and everything. Good evening, Mihir. So we'll begin the session now. Just give me a second. Is my screen visible to everyone? Let's do it. Yes, let's do it. Is my screen visible, guys? Great, my screen is visible. So before starting the session, let's just do a quick recap that what we did in the last class. In the day 3 of this bootcamp, we did the mathematical intuition on XGBoost. So what is this XGBoost? This is a machine learning library that is used for both classification and regression problems. So what is this classification and regression? When labeled data is given to us, we call it classification problem, and when we have to predict a continuous value, we call it regression. Okay. When we have to predict a continuous value, we call it regression. And when some kind of classes are given to us and we have to choose among those classes, then we call it classification problem. Okay. Now, what is this gradient boosting is? Gradient boosting is a machine learning algorithm with one major problem. So what is that problem? The problem is nothing but overfitting. Sir, what is this overfitting? Whenever our model is highly accurate on training data, highly accurate. Whenever our model is highly accurate on training data and very low on testing data, then we call that condition as overfitting condition. Hi Swapnil. Okay. So whenever our model is highly accurate on training data, but it has very low accuracy on testing data, then we call it overfitting condition. Okay, sir. To avoid this overfitting condition, XGBoost is performed. XGBoost is nothing but extreme gradient boosting, or we can say a library which we use for both classification and regression. Now, sir, what are the advantages of XGBoost? These are some of the advantages of XGBoost. Firstly, it is open source implementation of boosted trees. Second, fast and efficient implementation. Third, good choice for default splitting criteria and criteria for when to stop splitting. Built-in regularization to prevent overfitting. Gradient boosting was discarded because of this problem, overfitting. That's why this XGBoost here has built-in regularization method to prevent overfitting. And it is a highly competitive algorithm or library we can say for machine learning competitions. So these are the advantages of what we can say XGBoost. Then we saw in an example through which we tried to understand the mathematical part behind XGBoost. So first we took a data set, and based on that data set, we just tried to make a tree based on the height feature. We splitted that height feature into two parts, that is smaller than equal to 5 and greater than 5. On those two features, we call it child 1, child 2 and root. Then we calculated the similarity weight. What is the similarity weight? Nothing but the summation of all the residuals divided by summation of probability into 1 minus probability. So now what is this residual and what is this probability? The probability is nothing but the average of the output. 1 plus 0 by 2. Because here the output is in total two categories, 0 and 1. So the average, that is 1 plus 0 by 2, is the probability, that is 0.5 we can say. And sir, what is this residual here? Residual is nothing but output minus probability. So here we can see the output is 0. So output minus probability. Probability is 5, 0.5, right? So 0 minus 0.5 is minus 0.5. 1 minus 0.5 is 0.5. Again 1 minus 0.5 is 0.5. And that's how we get all the values of residual. We call this residual 1. Then moving forward, we calculated the similarity weight for C1, that is the child one, that comes out to be 0, right? Then we calculated the similarity weight for child 2. That comes out to be 0.33. And similarly, we calculated the similarity weight for root as well, which comes out to be 0.14. Now, based on the similarity weight, we tried to find the gain. Now, sir, what is this gain? Gain is nothing but similarity weight of child 1 plus similarity weight of child 2 minus similarity weight of root. Sir, why are we finding this gain? Because this gain is very much important. This gain is very much important to tell us which feature we must choose to split our tree. This gain here we have calculated is for the height feature. Suppose the gain for this height feature is 0.21 and the gain for the weight feature is 0.11. Suppose the gain for weight is 0.11. Then which feature to choose on the top? The feature that have the higher gain value. So in this case, the higher gain value is of height, so we'll choose height at the top. Okay, sir, got that. Then here we have further divided this height into weight, and based on that, we have again calculated the gain, and that's how we split the tree furthermore as well. Now, sir, what is this post pruning? Post pruning is a concept in which we calculate the cover value with the formula probability into 1 minus probability. After this cross cover value, if the cover value is smaller, if the value gain value of a branch is smaller than 0.25, we will cut that branch. If the value of gain of any branch is smaller than 0.25, we will simply cut that branch. So it's written here as well. If the gain value is smaller than cover value is 0.25 in this case. If the gain value is smaller than cover value, then we can cut the branch. Then we have discussed the base model. So XGBoost is a method in which we make more than one tree. First we make a single tree, then based on that tree we will find the output of the model. Then based on that model we will find another new probability. Based on that new probability we will find residual 2. Based on that residual 2 we will calculate tree 2, or we can say tree 1. Then similarly tree 2. Then similarly tree 3. So that's how XGBoost works. It is a multi-tree model, you can say. So after the output, we calculated the sigmoid function. The sigmoid function tells us is basically a classification activation function, which tells us whether the value is 0 or 1. So based on the sigmoid function, we calculated the new probability, and based on this new probability, here you can see the new probability 0.6. Based on this new probability, we have calculated residual 2. How we have calculated residual 2? Nothing but output minus new probability. So the output is 0, new probability is 0.6. So 0 minus 0.6 is minus 0.6. Similarly, we have calculated this residual for others as well. So that's how XGBoost is worked, like the mathematical intuition behind XGBoost. Based on residual 2, we will again create another tree. So please explain sigmoid again. Okay, Dikshas, listen. First, after getting the we can say cover value, we just check that if the gain value is smaller than the cover value, then we can cut the branch, right? So suppose the gain value is greater, right? So we will make a base model. We will find the output of the base model. How can we find the output of the base model? The formula is log of probability upon 1 minus probability. This is the formula to find the output of the base model. So, okay sir, the probability here is 0.5, right? The probability that we calculated is 0.5 and 1 minus probability is again 0.5. So this becomes log 1 which is equal to 0. Log 1 which is equal to 0. Okay sir. Now we put this 0 in another formula to calculate the value of y, which is further used in sigmoid. Okay sir. Now sir, what is this 0 here? This is nothing but the output of the base model. So what is this 0? This is the output of the base model. Okay sir. What is this sigma here? The sigma is nothing but the sigmoid function. Okay sir. Sir, what is this alpha here? Alpha is the learning rate. And in this value, in this case, we are taking the value 0.1. Sir, what is this 1 here? Okay, good question. What is this 1 here? So right now, we are calculating for first row, suppose. Suppose we are calculating the value for first row. Okay, so we have to go smaller than equal to 5. Then we have to go in the weaker section to find the answer, right? So in the tree, first we will go to smaller than equal to 5, then we will go to weaker section to find the answer, right? So similarity weight here of this section is 1. The similarity weight here of this section is 1. So the value 1 here, the value 1 here is nothing but the similarity weight of that section we have to find the output of. So the similarity weight 1 comes over here. So after putting the values, suppose the answer is sigma 0.1. So what is the sigma? This is the sigmoid function. What is the sigma? This is the sigmoid function. So what is the formula for the sigmoid function? The formula is 1 upon 1 plus e to the power minus y. So what is this y here? Y is nothing but 0.1. Y is nothing but 0.1 here. After putting the 0.1, we got 0.6. Suppose we got 0.6. So this is our new probability. That's how sigmoid works. Is this clear? The mathematical part is clear to everyone? We have discussed this in the last lecture as well. Last day 3 maybe. Yes, day 3 as well. Come on guys, reply in the chat. Clear to everyone? Is everything clear? Yes sir, clear, great. So let's move on to the practical part now. So we will use Google Colab. Great, great. Clear to everyone. So we'll use Google Colab now. So I have created a new notebook in which I'm going to train my model. So first of all, I'm going to connect my notebook. From here, you can see the connect button. So first of all, I'm going to connect my notebook. Then I'm going to just upload the matches.csv file. You can get that matches.csv file. You can download that file. Just a second. I'm showing you the file. Come to kaggle.com. In Kaggle, go to the datasets portion here and just search for IPL. So here the second dataset, IPL complete dataset 2008 to 2024. This is the dataset we are using, and within this dataset, just come to this matches.csv part, not deliveries.csv. Come to this matches.csv part and download the dataset. So this is the dataset we are going to use. This matches.csv is the dataset that we are going to use. So I have already downloaded this dataset, so I'm going to use that only, but you guys can download the dataset. So just a second. I'm going to upload that dataset. And this dataset was provided to in the group as well, in the day 2 material. When the notes were shared for the day 2, this dataset was provided as well. So here I have uploaded the matches.csv dataset. Great. So sir, how to begin with the practical part, or how to begin with the training? First of all, we will import all the necessary libraries that are required to train a model. The first library, just a second, the first library we are going to import is NumPy. So I am importing NumPy as NP. Okay, sir. Oh, sorry, as NP. Then I am import pandas as PD. We have already learned these two libraries, NumPy and pandas, right? Then I am going to import, from sklearn dot model selection. So what is this sklearn? Sklearn is scikit-learn. This is the basic library used for machine learning. sklearn underscore model selection. I'm gonna import train test split and one more library I'm importing, that is cross val score. I'm going to import these two libraries, that is train test split and cross val score. So what is this train test split now? Train test split helps you to split your data into training part and testing part. Train test split helps to split up your data into training part and testing part. And sir, what is this cross val score? It helps to train your data in multiple parts, we can say. Okay, sir. Now I'm gonna import from sklearn dot metrics import accuracy score. So what is this accuracy score? It helps us to find the accuracy of our model. Okay, sir. Now I'm going to import from XGBoost. So this is the library XGBoost that we are going to use. From XGBoost, import XGBoost classifier. XGB classifier. As I am doing a classification project, so I am importing XGB classifier. Okay, sir. Now what? I'm gonna import from sklearn dot preprocessing import label encoder. Now, sir, what is this label encoder here? Let me verify which issue. No, just fill out today's and tomorrow's attendance and it would be okay. Don't worry about yesterday's attendance. Okay. So from sklearn.preprocessing, import label encoder. So now what is this label encoder? Suppose you have data like Delhi, Mumbai, and Bombay, and you have to train your dataset. So your dataset cannot train on textual data. Like right now, it can train on textual data, but right now we are converting that text into some values. Like we will assign Delhi to 0, Bombay to 1, and suppose Chennai to 2. So Delhi 1, Delhi 0, Bombay 1, and Chennai 2. So we'll assign the values like this. So this can be done very easily with the help of label encoder. Okay, and then I will also so these are the basic libraries that I'm going to use while training the model. Okay, so NumPy, Pandas, train test split and cross validation, accuracy score, XGB classifier, and label encoder. Okay, sir. Now, first of all, I'm going to load my dataset. How? So we have to load our dataset using pd dot read csv, and we have to give the name of our dataset, that is matches.csv. Now if I try to print df, you can see the dataset here. So this is our dataset. Okay, now if I have to print the top 5 rows of the dataset, I will just simply write df.head, sorry, df.head. It will print the top 5 rows of the dataset. Till now everything clear? Everything clear till now? Just write clear if everything is clear. Come on guys, write clear in the chat. Yes, Gaurav Sharma clear, Sajida clear, Isu clear, Khushi clear. Chalo, great. So moving forward. Sir, is there any null value in this dataset? Yes, there can be a null value in this dataset. But sir, there are 1095 rows in this dataset. How can we find a null value? So to find, sir, are we going to visualize too? No, the visualization and all the data analysis things I've done in the day 2, right, Mihir? When we have done the matplotlib part, I have showed you 1 or 2 graphs, right, in the day 2 of this bootcamp. In today's lecture, we will be doing the training part only. I will first show you the training through XGBoost, and then the time, if the time is left, then I will show you the training through linear regression, logistic regression as well. Okay, so moving forward. Now, is there any null value? Yes, there can be a null value. How to find that null value? With the help of df.isNull. IsNull is a function which helps us to check if there is any null value or not. Dot sum. So this sums up all the null values, and I'm going to print that. So as you guys can see, there are 51 null values in the city column, 5 null values in player of match column, 5 null values in winner column, 19 null values in result margin, 3 in target runs, and 1074 null values in method. Okay, Mihir, okay. So yes, we have these null values. Okay, sir. But right now, while training the model, some of these columns are not even necessary to me, like the column ID here. I'm not going to use this ID because it has no reference to my model. Okay, sir. Then the column like super over. it has no reference or no, like I cannot use this super over because it will not provide me any good while training the model. And this umpire 1, umpire 2, these are not the, we can say, good features to train the model on. And this method feature, method column as well. So I will use only specific features. So I don't have to think about these features like method, umpire 1, umpire 2 and all. Okay, sir. Sir, how can, but the problem is here. If you can see winner 5, that we have 5 missing values in the winner column. We have 5 missing values in the winner column. So how can we remove that missing values, sir? Okay. This simple command df equal to df dot drop na. This drop na helps to remove the missing values. Drop na helps to remove the missing values. And if I provide subset equal to, subset is the column name that from which we have to remove the missing values, and the column is winner over there. So now if I try to print the df, or sorry, if I try to print the sum of null values, if I try to print the sum of all the null values, you guys can see winner have 0 null values. Is this clear? That's how we can remove the null values. If everything clear, then write clear in the chat. How can we remove the null values? Great, Krishna Gaur, Nasir, great. Sajida, great. So moving forward. Okay, sir. Sir, can we add some columns from our side as well? Yes, we can add some of the columns from our side. Sir, how can we add those columns from our side? Yes, Diksha, the row is removed completely, having the null value from the winner portion. So can you just a second? Is it okay now? How can we find all these different commands and learn about them? You can just go to Google, and the different machine learning, you can say, commands and everything are provided over there. Or you can just go through the scikit-learn documentation as well to find all these commands and everything. But these are the basic pre-processing techniques that you will apply in each and every model, like the finding the sum of all the null values and removing some columns, removing some rows. These are the basic pre-processing techniques that you will apply in each and every model. So by the time doing 1 or 2 times, you will get hands-on experience on these kind of pre-processing techniques. Is this clear? Okay. So moving forward. So can we add 1 or 2 columns as well? Yes, we can add 1 or 2 columns as well. So while predicting who is gonna win the match, there's a very big advantage based on home advantage. Like if I am a player of Delhi and the match is in Delhi, then I have an advantage that I have already played in the grounds of Delhi Stadium. So there's a very big advantage that is called the home advantage. So we will add the home advantage column here as well. Like if one of the team and the ground they are playing in belongs in the same, we can say, city, then the team have the home advantage. So we'll add that column, and for that column I have a set over here, dictionary. So why this dictionary? Why are we using this dictionary? We are using this dictionary because the name over here, you can see, as Chennai Super Kings. So from this name, we cannot know that this city is Chennai. So we are saying this. The key value is Chennai. So the value is Chennai. If the team name is Kolkata Knight Riders, so the value is Kolkata. Like the machine cannot detect from Kolkata Knight Riders whole name that the team belongs to Kolkata. Or it cannot detect from Sunrisers Hyderabad that the team belongs to Hyderabad. So we have to make a dictionary which will show us which team belongs to which city. Okay, so here I have created a dictionary. Okay, sir. Now, sir, how to make that column? How to make that extra column? For that, first I will create one another column, one temporary column we can say, that is team 1 home city. So this is the name of that temporary column, which is equal to df dot. What is this df? Df is the data frame I'm using. Sorry, df not dot team 1 dot map. So what is this map here? Just give me a second. I will explain you this. Team underscore city underscore map. Now, sir, what is this map over here? Map is nothing, but it will check if the team 1 is playing in the same city or not. It will map the values. It will combine the values, you can say. Combine the values together. Okay, sir. So we have to do the same for team 2 as well. Yes, sir. If I have done for the team 1, I have to do it for the team 2 as well similarly. So df team 2 home city equal to df of team 2 dot map team city map. So I have mapped the values, or we can say I have joined the values of team 1 and team 2 with this their team names. Okay, sir. Just ignore these warnings and everything. Okay, sir. We have mapped the values. Now what to do, sir? Now I will create the columns for home advantage. That is df home advantage team 1. This is the column name, say, is equal to df dot team 1 underscore home underscore city is equal to, sorry, not dot over here, df city. Now, sir, what is this? So I have created a column df home advantage team 1. Can you share the dictionary for teams and cities? So this will be shared, and this whole IPYNB file will be shared to you guys at the end of the day 4. Okay, so sir, what is this now? DF home advantage team 1. So this is the column that I have to add. Okay, sir. Now, sir, what is this? DF team 1 home city equal to DF city. Now this line here checks if the team 1 home city is equal to the city they are playing in. It checks if the team 1 home city is equal to the city they are playing in. If they both are equal, so it will give one value in this column home advantage team 1. If both of them, team 1 home city and the city they are playing in, is common, or we can say equal, then we will add 1 to the home advantage team 1 column with the help of dot as type int. Okay, sir. Now, sir, what to do? We will write the same line for team 2 as well. I will just change the team name. Team 2 home city over here and home advantage team 2. Okay, sir. As you can see, this is successfully run. Okay, sir. Now if I try to print the data frame, at the end of the data frame, you can see this home advantage team 1 and home advantage team 2, right? If you can see, there is one value over here and zero value over here. What does this one value and this zero value means? It means that team 1 in this particular case have the home advantage and team 2 does not have the home advantage. So in second case, they both have 0. This means both of the teams does not have home advantage. Okay, sir. In the third case, it's similar. Both of the teams does not have home advantage. Fourth case, again the team 1 have home advantage, and this goes on. Like in this case, the second team have home advantage, and like this. So this is how we will add the home advantage column. Is this clear? Is this clear to everyone? That how can we add extra columns or extra features to train our model on? If everything clear, then type in the chat clear. Everything clear, guys? Yes, sir. Clear, sir. Clear. Come on, guys. Be fast. Clear. Clear. Ankur Ghosh, Diksha Garg, Suru Dada, Gaurav Sharma. Clear. So that's how we can add specific columns in our dataset as well. Isha and Sajida, Sneha, Rajni, Swapnil. So till now maybe it's clear to everyone. Okay. So moving forward. Sir, what are we going to do now? I am going to split my dataset into X and Y. Okay, sir. X. Sir, what is this X and what is this Y? So X is nothing but the dataset without the winner. And sir, what is Y? Y is the winner column. So we have to split the dataset into two columns, into two categories, we can say, in which one category consists of the whole dataset without the output value, and the other data and the other Y consists of the output value only. So here I'm converting X equal to df, and I'm going to use the columns like uh, city and I'm going to use some specific columns only, and the column like venue and team 1, team 2, then toss winner, then toss decision, then target runs, then target overs, then home advantage. Then I'm going to add these two columns over here. That is the home advantage team 1 and home advantage team 2. And the home advantage team 2. So I'm going to use these features only. So in the X, I'm going to use these features only. So what are the features? Home advantage team 2, home advantage team 1, target overs, target runs, toss decision, toss winner, team 2, team 1, venue and city. So according to me, these are the basic features that we have to use in this model that are basically dependent on which team is going to win. Okay, sir. And sir, what will we put in Y? Y is nothing but df winner. We'll put only the output column in Y. Okay, sir. I will run this branch. Great. So here we have splitted our dataset, right? Now what to do, sir? After splitting the dataset, we know that many columns like team 1, team 2 and venue and city, these columns are nothing but the we can say textual columns. These are not categorical, these are not numerical columns. So now I am going to convert these text columns into numerical columns. Why going to convert into numerical columns? Because this will make the we can say training part more easier. Okay, sir. How to convert now? So I will write a loop for column in X. What is this X? X is the data frame or like all the features I have selected for training particularly. X dot select underscore D type. So what is this D types? The type of the we can say column. Like if there are only integer values in the column, the D type is int. If there are string columns, the D type is string or the object we can say. D type include equal to object. So if the D type is object as well, it will be included in this uh, loop of ours. Dot column. So this loop will go through all the features of X. Then X of column equal to label encoder. We have defined label encoder above, right? Here. So what is this label encoder? It helps us to encode the we can say like this is Bangalore, right? So it will give Bangalore a value 0, then Chandigarh a value 1, then Delhi a value 2. So whenever we are going to use Bangalore again, we will put 0 instead of Bangalore because the value 0 is assigned to Bangalore. Okay, great. So label encoder dot. How to apply this label encoder? We will use fit underscore transform function. So with the help of this fit underscore transform, we will be applying this label encoder. Okay, sir. Where we have to apply X of column dot as type string. So it will convert all the string types entities or we can say data points into numerical part. And we will run this part. Okay, sir. It successfully run. Now, similarly, we will do this for the Y as well, for the Y column as well. Because we know that the Y column consists of all the winners. So the name of the winner is also string type. So we'll label encode the winners as well. So Y, we can say Y is equal to label encoder dot fit underscore transform Y. So this will encode all the values of Y. Okay, sir, it's clear. Now if I try to print X, you can see all the values of X are encoded now. City, venue, team 1, team 2, all of these have specific values. And if I same way, if I try to print Y, you can see the values of Y are also encoded now. So till now is it clear how to encode the values? Is this clear? Write clear in the chat if everything is clear. Clear. Come on, guys. Clear in the chat. Yes, sir. Yes, sir. Clear. Great. So this is how we will encode the values. Okay, sir. Now what to do, sir? Now we will split our dataset into training part and testing part. How to split our dataset, sir? We will first define the variables x train, x test, y train, and y test. So these are the variables. X train consists of the X data frame training part and X test consists of X data frame testing part. Similarly for the Y equal to train test split. We will give X, comma Y, comma test size. Test size equal to, we will say 0.2. So now what is this test size over here? Test size 0.2 means that 20% of our data will be converted to testing part and the rest 80% will be the training part. Okay, sir. Now stratify equal to y. So this will just convert into a singular, we can say, matrix. And what is this random state? You can put any value in this random state. Equal to, I am currently putting 42. You can put any value in this random state. This helps us to mix up or uh, train your data in a mixed way, we can say. Okay, sir, we have splitted the data. Now we will split this data again. Sir, why again? This time we will split the data from the training part only. We have one training part right now and one testing part. Now among this training part, we will again split this data into training part and validation set. So that on the training part we will train the data. With the help of validation set we will validate the data, and with the help of test set we will test the data, we will test the model. So among the training part I will again split the model. So x train full, maybe suppose the name is this, and x val is for validation set, comma y train full, comma y val. So y train full is the training set and y val is the validation set, is equal to train test split x train, comma y train, and same I will put the test size equal to suppose 0.2, as I'm going to 20% to the validation part. Then stratify equal to y and y underscore train. I'm going to stratify the y underscore train column this time, and random state equal to 42. Again you can use the any value for the random state part. Now I'm going to run this cell and this is successfully run. So my data is now split into training and testing part. So if I just print x underscore train dot shape, just a second, print x underscore train dot shape, comma x underscore test dot shape, comma x dot shape. So you guys can see we have 872 data points as training data, 218 data points as test data, and total data points are 1090. Is this clear to you guys? So moving forward, Sir, we have successfully splitted the data. Now what, sir? Now I'm going to call my model as model equal to xgb classifier. So here I have defined my model xgb classifier into this variable name model. Okay. Now, sir, what? I am going to fit all this training data into my model with the help of dot fit function. So dot fit, I'm going to first give the training and testing data full x train and y train, in which the model will train x train full, comma y train full. Okay, sir. Now, sir, what? I will give it the evaluation set, or we can say validation set. So what is this evaluation or validation set? This is nothing but the uh, x underscore val, comma y underscore val. This time we have splitted the data again, right? Here x underscore val and y underscore val is used for validation set, or we can say evaluation set, eval set. Clear to everyone? Okay, sir. Now I will put one more command, verbose equal to false, and I will successfully run this cell. So as you can see, my model is trained successfully. So now what is this verbose? If I will just simply remove this command, so you will see I will get all these lines like validation, mlog loss equal to something this. So to prevent all of these statements, I'm going to use verbose equal to false. This will just simply give me the output. And that's how our model is trained. So we have trained our model successfully. Okay, sir. Now, sir, how can I check the accuracy of my model? How can I check the accuracy of my model? So to check the accuracy of model, we will just simply write train underscore accuracy equal to accuracy score. So what is this accuracy score over here? We have defined this accuracy score here. From sklearn.metrics import accuracy score. So we have imported this accuracy score, which helps us to find the accuracy of the model. So train underscore accuracy equal to accuracy score. Now, sir, what is the accuracy? How to find the accuracy? I will just use y underscore train underscore full. This is the y train, or we can say the outputs for the training model, for the training data. This y train full is the outputs for training data. And I will use model dot predict x train full. Now what is this y train full and x model dot predict x train full? So y train full over here is the output of training data. Okay. Now, sir, what is this model dot predict over here? Model dot predict predicts whenever you give the data. Now after training, whenever you give the data to the model, it will predict an outcome. So model dot predict helps us to give that outcome. Okay, sir. What is this x train full? This is the training data itself. Okay, sir. Now, sir, how does this accuracy score works? It will compare the output of the training data with the output given from our model of the training data. So this is the actual output of the training data y train full, and this is the data output given from our model. So it will compare both of them and give us the output. So this is how accuracy score works. Okay, sir. Sir, how can we calculate the accuracy of testing data? Similarly, just we will copy this line, paste this line. Instead of train, we are going to find the testing data accuracy. Accuracy score we'll just write y test over here, because we are finding the accuracy of testing data right now. So y test and x test. Okay, sir. Now the accuracy is scored in this training ACC and test ACC. So now we are going to print the accuracy. Print accuracy training. So to find the training accuracy, I'm going to just I have found the training accuracy. I'm going to print it now. So train underscore ACC. Now, sir, what is this dot 2f? This dot 2f denotes that I am going to print only the after the point, after the decimal value. I'm going to print only two values. After the decimal, I'm going to print only two values. Like if I will remove this dot 2f, and now if I try to print the accuracy, just a second, testing accuracy and test. Yes, if I print the accuracy, you can see the accuracy is too much lengthy. There are too many points in the accuracy, so I will just use dot 2f. So it will print the accuracy till second decimal point. Dot 2f. So as you can see, the training accuracy is 1 and testing accuracy is 0.56 as 56. This 1 over here denotes 100% and this testing accuracy denotes 56%. So this means our model is 100% trained? No, this means this is the condition for overfitting. It means our model is very poorly trained, because whenever we deal with this overfitting condition, it means our model is not good. As you can see, the accuracy over here on testing data is 56, which is okay accuracy, we can say, but the accuracy on training data is 1. So how to deal with this now? We will deal with this with the help of hyperparameter tuning. So what is this hyperparameter tuning? We will you what I can say is hyperparameter tuning is a way to suppose train our data on more specific features. Like I have told you guys about the learning rate, right? In the third lecture, maybe third day of this bootcamp. So learning rate, we haven't used learning rate over here anywhere. But with the help of hyperparameter tuning, we will set the learning rate on which our model will train and some other features as well. So I will train my model more deep, in a more deeper way, we can say, to deal with this 100% accuracy, or we can say overfitting. Sir, how to deal with this hyperparameter tuning? So we will just use one library from sklearn dot model selection import grid search CV. So what is this grid search CV? It is a library used for hyperparameter tuning. Okay, sir. Now I have to give some param grids. So what is this param grids? Just wait for a second. I will tell you guys. I have to give this some param grids to train my model on. Okay, sir. What are these param grids? This param grids consist of max underscore depth, 3,5 suppose. So what is this max underscore depth? This tells us the depth of the tree till which our model can go. So I am giving here two values. So I'm going to test this on two data sets, or we can say two times. Two times we can test this two times. When the value is 3 as well, and when the value is 5 as well. I will test it on both. and in the end I will choose the best parameter, that is over 3 is better or 5 is better. Okay sir, what else can we use? We can use learning rate. Okay sir, what are learning rates are good for training a data? It's like 0.005, sorry, 0.05, or we can say 0.01 and zero point 0.1. I'm going to train on the basis of these three learning rates. I'm going to train my model on these three learning rates, right? Okay, sir. What else are the parameters? Suppose n estimators. So I'm going to give the values 100, 125, and suppose 75. Then subsample is the like from the overall sample, how much portion are you using is the called the subsample, we can say. So subsample is I'm taking 0.7, 0.9, and suppose 1.0. This is the subsample I'm going to take, and I'm going to use one more parameter, that is called sample underscore by tree. You can go and see the documentation of all these parameters. There are many more parameters as well. You can see all the documentations online. So 0.7, it is available with the scikit-learn or hyperparameter tuning. 0.7, 0.8, and 1.0. So these are the parameter grids that I am going to use. Just a second. Learning rate. Okay, sorry, I am missing a comma. Yes. So it runs successfully. Now based on these parameters, I am going to train my model. So I'll just write grid underscore search is equal to grid search CV. This is the library that I have imported. Now I will train the model, that is estimator estimator is equal to model. What is this model? Model is nothing but the XGB classifier. It will be working on my own model, XGB classifier model, this hyperparameter tuning. Okay, sir. Now there is a parameter param grids that we have defined over here. So I will write only param grids here. Okay, sir. Sorry, this is param grid. Now CV. CV is nothing but in how many parts a data set is divided into. So I'm going to divide my data set in 3 parts, we can say. Then n jobs. N jobs just makes our training, we can say, a little bit faster. Then scoring is equal to accuracy, and verbose equal to 2. So scoring equal to accuracy means the score, or the, we can say, the training part, it will be based on the accuracy of our model. Then I will just fit my model grid underscore search dot fit, and I will fit all the training data on this, X train full and Y train full. So now this 3, sir, what is this 3 over here? This 3 is nothing but CV equal to 3. That means our model or data set is divided into 3 parts. So now what is this 162 over here? If you see, we have 2 values here, right? We have 3 values here, 3 values here, 3 values here, and 3 here. So this 162 is nothing but This 162 is nothing but 2 into 3 into 3, to 3 into 3 into 3. So 3, 3, 3, 3 and 2. If you calculate, it will be 162. And this folds 86 is nothing but 3 folds into 162. So 162 into 3. So training this will take 2 to 3 minutes. Till now, is everything clear? How we are going to train our model? Grid search CV and random search CV. What is the difference? They both are used for basically we can say grid search is used for hyperparameter tuning. You guys can go and see all the differences and like how to use hyperparameter tuning in a more effective way and everything. You guys can use your values as well. Just try and put some different value and just you try to run the model again. Maybe you get a better accuracy than me. Yes, the model is currently suffering from overfitting. That's why we are doing hyperparameter tuning. Please explain the last part again. Which part is not clear? Diksha, which part is not clear to you? Can you please tell me? So it's like 2 minutes, but it's still training. So it will take 1 or 2 minutes more to train the model. So whenever we are doing the hyperparameter tuning, recent I have done. So the value you choose there's some specific recommended values. No, there are not some specific recommended values. Like we always try to take the learning rate between these values, like 0.01 and 0.1 and everything. Just a second. Okay, so just ignore these warnings for now. So basically, we always try to take the values of learning rate like 0.05 and 0.01 and everything between these, and these are the like common values used. But you can use your values as well. Just try to put some other value and try to train the model again. Maybe you get a better accuracy than me. So this is kind of a try and hit method, but there are specific conditions when we can say that this value will perform better than the other value. So I have also tried many values, but these are the parameters on which I'm getting a normal or decent accuracy, we can say. Okay, sir. Now, sir, what are the best parameters? Do we know the best parameters? We will just use print grid search dot best underscore params underscore. So this will just show us which all parameters are used to train our model. So here in cost sample by tree, I've used 0.7, 0.8 and 1, right? So among all these values, my model is trained on best on 0.7. Okay, sir. The learning rate is best trained on 0.5. But I have chose 0.05, 0.01 and 0.1. So among all these values, the best value is 0.05. And similarly, all these are the best values chosen. Okay, sir, got this. These are the best parameters. Now, sir, now we will just try to find the accuracy among all these parameters. Okay, sir, how to find the accuracy? We will just define best model is equal to grid search dot best params. Sorry, best estimator. Okay, and we will just fit the model. Best model dot fit, and we will put the values like the training data set x train full and the y train full, and the evaluation set as well, that is eval set is equal to xval and yval, and were both equal to false. So this is nothing new. I have also fitted the model over here. You can see just a second. Yes. So here I have chose the model, but this time I am using the best model with the specific parameters, we can say. Okay, so this is how we will train the model again. Okay, sir. And in the similar way, we will find the accuracy. Just a second. Yes. Similarly, we will find the accuracy as well. So the accuracy will just make a little changes. Model.predict. Instead of model, I will write best underscore model. And in the second as well, best underscore model. So now if I try to run this, you can see the model accuracies. In the testing accuracy is 61 and training accuracy is still 86. So our model is still a little bit overfit. Why is an estimators not trained? Just a second, guys. Maybe okay, this is DORS. Now if I try to train on these parameters, there was a warning as well before that the estimators were not trained, because I have, instead of estimators, I have just, like, instead of O I have written E over here. So that's why the n estimators were not trained on the n estimators parameter. So the value is okay. So here, whatever after tuning hyperparameters, the accuracy of the model is still unproved. I mean, still suffering from overfitting or underfitting. So you have if the after the after hyperparameter tuning, if the model is still suffering from overfitting and underfitting, we use some other kind of model. We sometimes try to just make the features change or the pre-processing part again. Like, we have to do more complex pre-processing as well sometimes. Right now in this model I have done very simple pre-processing, like just remove the null values from the winner column and everything, and added one or two more columns. But in complex data sets we have to do a lot of pre-processing, complex pre-processing as well. Okay, what was the final registration task for IPL certificate? Can someone help me out, please? Okay, so just, it will take 1 more minute, so maybe we will get a better accuracy this time. So this accuracy is also okay, we can say. So our testing accuracy is 61% and training accuracy is 86. The model is still a little bit overfit, we can say right now, but these are accuracies are also good, we can say. So if you guys try to predict which team is gonna win, so it totally is based on the player's performance, right? And we are not using any kind of player performance right now. So based on other features, this 60% accuracy on testing data is very good as well. And this is for educational purposes only. So like it's like 2 minutes already while the cell is running. Maybe it's about to be done. So everything clear till now, guys? Reply in the chat. Everything till now is clear. So yes, fitting three. So yes. So it is now trained on n estimators as well. Now if I try to print the accuracy, okay, so the overfitting condition is resolved maybe now, as the testing accuracy is around 60 and training accuracy is 69 or 70, we can say. So there's a difference of 10%. So we can say overfitting condition is now resolved. So the accuracy on training data is 70% and testing data is 60%. So we can say, according to the data set we are given, we have trained a pretty decent model. Now what you guys can do, You can put different values in these param grids, different hyperparameter methods you can use. Just go to Google, go to scikit-learn documentation, and try to find different parameters and different hyperparameter tuning methods and everything, and try to train the model in a more effective way. If we use random search CV, the accuracy may be best than grid search CV. So you can use random search CV as well. I'm just showing you an example of how to do hyperparameter tuning, because here I've got 100% accuracy. But after this hyperparameter tuning, I've gotten this 70% accuracy, from 100 to 70, and the testing accuracy is 60. So maybe the overfitting condition is resolved now. So is this clear to everyone? Is there any kind of doubt right now? We have successfully trained our model, and in the next class we will be seeing the final things, like the, we can say, how to host the model, how to push it on GitHub, then how to deploy it on render and everything, basic things. Is everything clear till now? Just write clear in the chat. Is everything is clear? Clear, clear. Great, great. Yes, done. Yes, sir. So now try to implement this model again by yourself. Try to just use some different parameters based on this model, and maybe you guys can get a better accuracy than me. So just hit and try different parameters now. Or you can guys can go to Google or some documentation and read about some other hyperparameter tuning techniques as well, and then apply those techniques. Apply one or two other models like logistic regression or any other model. So we'll surely try, sir. Thanks a lot. So we'll end today's session now, and day 5 we will be doing the deployment and everything. Testing accuracy. The testing accuracy is here 60%. So that's it for today's session, guys. Hope you all enjoyed. Okay, so let's meet tomorrow for the day 5, or we can say the final day of the bootcamp. Thanks a lot, guys, for attending the session.